So example on this minimum and maximum value. So a rectangular box without top or open top is of value 32 meter cube. What was the dimension? So x, y, z be the dimensions, and in last lecture we have seen that the fxy is this function, and now we have to find the values of x and y for which this function is minimum. We have to remain the surface area minimum, and the surface area is this function, that is this function 64 by y plus 64 by x plus x into y, the simplification of this, that surface area. And we denote this surface area by fxy, that is we have to we have to find the values of x and y for which this function fxy is minimum. And so the same procedure, that is to find critical points, then find values of capital A, capital B, capital C, delta, and then we have the values of x and y. So first find the first partial derivatives of with respect to x and y. These are the derivatives. 64 by minus 64 by x square. Derivative of 1 by x is minus 1 by x square, and derivative of xy with respect to x is y. Similarly, the derivative with respect to y is this, and then fxx, the second order derivative, that is the derivative of this quantity, minus 64 x divided by x square means x raised to minus 2, and the derivative of x raised to minus 2 is minus 2, x raised to minus 2 minus 1, that is x raised to minus 3, that is we have this answer. Similarly, fyy is this, and fxy means what? The derivative of fx with respect to y, the derivative of minus 64 by x square is 0, and the derivative of y is 1, so fxy is 1. Then consider fx is equal to 0 and fy is equal to 0 for critical points or stationary points, and that is this is equal to 0, this is equal to 0. So solving this equation 1 and 2 simultaneously or independently. So from equation 1 we have y is equal to this 64 by x square. Substitute this value in equation number 2. That is in order to solve this equation 1 and 2, we add these two equations, subtract this equation, multiply, divide, or find the value of x or y from equation 1 and substitute in 2, or find the value of x and y from equation number 2 and substitute in equation 1. So we have the value of y is 64 by x square from equation 1. Substitute in equation 2, we have this. So after simplification, we have this, and take x as common, so minus x cube by 64 plus 1 is equal to 0. That is x is 0, or this bracket is equal to 0. This bracket is equal to 0 gives x cube is 64. That is x is 4, because 4 cube is 64. That is x cube is, x is 64 means x is 64 raised to 1 by 3. Third root of 64 is 4. Because 4x cube is 4 cube is 64. And x is not equal to 0 because x is the length, and length is not equal to 0 of the box, and that's why x is not equal to 0. X is equal to 4 is the is the value of x, and then x, if you substitute x is equal to 4, then from equation 1 we have either substitute equation, use equation 1 or use equation 2. That is substitute x is equal to 4. Then y is what? Y is 64 by x square is equation 1. 64 by 16, that is y is also 4. And so critical point is what? 4 is the critical point. 4. Okay, and then we have only one critical point. Then capital A, that fxx at 4. That is substitute x as 4 and y is 4 in that function fxx. We have this answer 2. And capital B is 1. Capital C, that is fyy at 4. We have answer 2, and then delta is AC minus B square, 2 into 2 minus 1, 4 minus 1, that is 3. Delta is greater than 0. Delta is greater than 0, and A is also greater than 0 because A is what? 2, and therefore the function fxy has minimum value at 4. That is that is x is 4, y is 4. Then find z as 32 by x into y. So 32 by 60, that is z is 2. So if we take x as 4, y as 4, and z as 2 as the dimension, that is length, breadth, and height, then the function, then what? Then the surface area becomes a minimum. The required dimension of the box are what? X is 4, y is 4, and z is 2. So these are the values of length, breadth and height, or dimensions of the box. If it remains the dimension as this, then the surface area becomes minimum, and the volume is 32. If we find volume of this box, then 4 into 4 into 2 becomes 32. These are the problems of extreme values and that is maximum and minimum values for function of two variables. So solve all the exercise problems of the maximum and minimum values of two variable functions. That's are shared with you through WhatsApp group. The problems, homework problems of this stationary points and what extreme values of the two variable function. Next point is Lagrange's method of undetermined coefficients. So the question is what? Explain Lagrange's method of undetermined coefficients to find extreme values. That is again the same method to determine the maximum values of the function of three variables. Now the previous topic is what? The maximum and minimum value or extreme values of the function of two variable. So now we consider the function of three variable f, x, y, z, and there is a method to find the extreme values of the functions of three variable, and the method is what? Lagrange's method of undetermined coefficients. So this question is also important as far as the exam concerned, that either theory is important or either theory or problem. The probability is 90%. That is either problem or this theory is important as far as the exam concerned. So what is the question? Explain Lagrange's method of undetermined coefficients. So let f, x, y, z be a function of three variables of x, y, z, which is to examine for extreme values. That is, we had to find the extreme value of the function f, x, y, z, which is to be examined for extreme values. And let x, y, z, these variables be connected by this relation, that f, x, y, z is equal to 0. The relation is what? By g, right? G, x, y, z is equal to 0. This is another relation between x, y, z. Is called constant. One constant is given, condition is given. Okay, so the function is given and the one condition is given in the example. So the x, y, z be connected by this relation, right? G, x, y, z is equal to 0. This is second. So the given function is f, x, y, z, and the given condition is what? G, x, y, z is equal to 0. This is the given condition. Phi is the notation. Phi, here is the phi notation. Phi x, y, z, right here, connected by the relation phi x, y, z is equal to 0. Since f, x, y, z is to have extreme value, then so how we can find the extreme value of the function? Any function, either it is single variable or two variable or three variable. Consider the first order partial derivatives equal to 0. First order partial derivatives with respect to x and y are equal to 0. So here f is the function of x, y, z. So consider the divided by x is equal to 0, divided by y is equal to 0, divided by z is equal to 0. That is, this is the necessary condition for, in order to find the extreme values of the function. That is first order, take the first order derivative is equal to 0. After solving these equations, we have the critical points, stationary points. That is, the function is either maximum or minimum at that points. So same condition for a single variable function, two variable function, and three variable function. That the first, consider the first order partial derivative is equal to 0. If the function is single variable function, then consider its derivative with respect to that variable is equal to 0. So since f, x, y, z is to have extreme value, that is maximum or minimum value, if what? Divided by x is 0, divided by y 0, divided by z is equal to 0. Okay, so so that we have divided by x dx divided by y divided by z dz is equal to 0, because all these divided by x divided by y divided by z is 0. This is the complete derivative of, yeah. This is suppose equation number 2. This is equation number 1. Phi xyz is equal to 0. The given condition is the equation number 1. Then differentiate 1 with respect to x. What is the equation? Phi xyz is equal to 0. Here write phi xyz is equal to 0. So what is its derivative? Complete derivative. Dava phi by dava x dx, dava phi by dava y dy, dava phi by dava z dz is equal to 0. So suppose this is equation number 3. The complete derivative of this function phi xyz is equal to 0. Then multiplying the equation number 3 by lambda and add in equation number 2, we have this equation. Take dx as common, dy as common, dz as common. And this equation satisfies identically if each coefficient of dx dy is 0. When this is equal, this equation is 0, if this bracket is 0, this bracket is 0, this bracket is 0. So we have the equation number 4, 5, 6. So solving this equation number 1, that is the given condition, and equation number 4, 5, 6 for x, y, z and lambda. That is, after solving this equation number 1, 4, 5 and 6, we have the values of x, y, z and lambda, and for which this function is extreme, that is maximum or minimum. So this is the procedure of finding extreme values of the 3 variable functions, and this procedure is called Lagrange's method of undetermined coefficients. So actual problem of this method, that is the problems of the extreme values of the 3 variable function. So what is the find the extreme value of the function x square plus y square plus z square. Denote this function as fxyz. If there is no notation, then we denote this x square plus y square plus z square as fxyz. Subject to the condition or constraint x plus by plus cz is equal to p. Subject to this condition. So we are given the function, 3 variable function and 1 condition. Okay, so this is the problem on the Lagrange's method of undetermined coefficient. There are 2 methods actually. There are two methods under this Lagrange's method. This is the first method, that is consider this function as fxyz and the condition as the phi xyz, that ax plus by plus cz minus p is equal to 0. That is this function, this condition phi xyz is equal to 0. Okay, so we have this. Then we construct the auxiliary function as capital F is equal to small f plus lambda into pi. That is, capital F is equal to x square plus y square plus z square. This function, that is that we have to find its maximum or minimum value, plus lambda into condition. So this is the auxiliary function. We consider the capital F, denote this capital F by this function, that is the function plus lambda into condition. Then differentiate this equation number star partially with respect to x, y, z and lambda, and equating with 0 we get. So with the differentiate this partially with respect to x, we have 2x, y square derivative 0, z square 0, lambda a is equal to 0, in bracket a is equal to 0. This is equation number 6. This is the derivative with respect to x, partial derivative of this equation star with respect to x, and equate it equal to 0. Similarly, the derivative with respect to y and equate equal to 0. Similarly, derivative with respect to z of this equation star and equate it is equal to 0. And then with respect to lambda, derivative of with respect to lambda, x square, y square, z square is derivative 0. And ax plus by plus cz minus p is equal to 0. This is equation number 5. And in each problem, this equation number 5 is the given condition. That is, derivative with respect to lambda is equal to 0 is the given condition. So after this, this is the common procedure for every example of extreme values of the 3 variable functions. After this, there are 2 ways to find the values of x, y, z. That is, we have to now solve this equation number 1, 2, 3, 4, 5 for x, y, z. That is, after solving this equation number 1, 2, 3, 4, 5 and solve the and find the values of x, y, z. So there are actually 2 methods. So what is the first method? Here is the first method. That is, if we have the values of x, y, z from equation 2, 3 and 4 independent of x, y, z. That is, if we find the value of x from out of these 3 equations, that is 2, 3, 4, in terms of lambda. If you have the values in terms of lambda of x, y, z, then find the values of x, y, z from equation 2, 3, 4. Here is the x is what? Minus lambda a by 2, y is minus lambda b by 2, and z is, that is, we have the values of x, y, z independent of x, y, z. That is, the value of x is not depend on y and z. The value of y is not depend on x and y. The value of z is not depend on the x and y. Okay, so it's, these are the values of x, y, z free from x, y, z. And if we does not have the values of x, y, z free from x, y, z, then another procedure, we will discuss that another procedure in the next example. So here we have the values of x, y, z. Substitute these values of x, y, z in equation number 5. What do we have? We have this equation, and then after simplification we have this, that is, and then take lambda as common, and then lambda, we have the value of lambda is minus 2p by a square plus b square plus c square, and then substitute lambda in the equation number this, x is equal to minus lambda a by 2. So if we substitute this, and after calculation we have x is equal to PA divided by a square plus b square plus c square. Similarly, if we substitute lambda in this equation, then we have the y is PB divided by a square plus b square plus c square, and similarly z is PC divided by a square plus b square plus c square. And then stationary point, we have the stationary point, this, that is value of x, y, and z. And then extreme value of the function. There is no similar, like to two variable function, there is no condition that is at this point the function is either maximum or minimum. In the, if there is two variable function, then for two variable function there is a condition, that is find capital A, capital B, capital C, and delta, and there, if this delta is greater than 0 and a is less than 0, then function is maximum. If a is greater than 0, then function is minimum at that point. But there is no such a condition to check whether the function of three variable is maximum or minimum at the stationary point. So we just find the stationary points and write that extreme value of the function at the point, at the stationary point, that is fx, yz. So extreme value of fx, yz is equal to, substitute in the function of fx, yz, fx, yz is this, x square plus y square plus z square. Substitute x as this value, y as this value, z as this value. We have this value. Okay, we have p square by a square plus b square plus c square, or as a value of extreme value of the function. So what is meaning of this extreme value? Extreme value means either maximum value or minimum value. Okay, so if there is no condition that this value is maximum or minimum at this point, just write the extreme value, means the maximum value or minimum value of the function. So this is the one procedure to determine the extreme value of the three variable functions. Okay, find stationary points and write the value of the function at that point, that is the extreme value. Similar problem is here. Again, one function is given and one condition is given, and we have to find the greatest value or maximum value of that function, and it is also given 64 by root 3. Okay, so we will solve this problem in the next lecture.